For the longest time, people have wondered about life around us, and astronomers have found a lot of planets. And now it looks like answering the question of alien existence will be easy for us with the new James Webb Telescope. Life might exist in the solar system where there is liquid water, like the subsurface aquifers on Mars or in the oceans of Jupiter's moon, Europa. However, searching for life in these places is incredibly difficult, as they are hard to reach, and detecting life would require sending a probe to return physical samples. Instead, many astronomers believe there's a good chance that life exists on planets orbiting other stars, and that may be where life will be first found. It takes an incredibly powerful telescope to detect these subtle changes to light coming from a potentially habitable exoplanet. For now, the only telescope capable of such a feat is the new James Webb Space Telescope. As it began science operations in July 2022, James Webb took a reading of the spectrum of the gas giant exoplanet WASP 96b, which is more than 1,000 miles away. The spectrum showed the presence of water and clouds, but a planet as large and as hot as WASP 96b is unlikely to host life. Nevertheless, the U.S. Space Agency said its multi-billion-dollar space telescope captured the signature of water on the giant gas planet WASP 96b, which orbits a star 1,150 light-years away. However, this early data shows that James Webb can detect faint chemical signatures in the light coming from exoplanets. Detecting life carrying capacity. Astrobiologists will study starlight that has interacted with a planet's surface or atmosphere to detect life on a distant planet. If the atmosphere or surface was transformed by life, the light may carry a clue called a biosignature. When light bounces off the surface of a material or passes through a gas, specific wavelengths of the light are more likely to remain trapped in the gas or material surface than others. This selective trapping of wavelengths of light is why objects are different colors. The pattern of missing light is determined by the specific composition of the material the light interacts with. As a result, by measuring a planet's particular color of light, astronomers can infer something about the makeup of the atmosphere or surface of an exoplanet. Because these gases leave behind extremely distinct traces in light, such as oxygen or methane, this technique can be used to detect the existence of specific atmospheric gases linked to life. It can also be used to identify unusual hues on a planet's surface. On Earth, for instance, plants and algae use pigments like chlorophyll to collect particular wavelengths of light to carry out photosynthesis. A sensitive infrared camera can be used to identify these pigments' distinctive colors. It would be remarkable enough to find an atmosphere in another solar system, but even yet, there is a slim possibility that one of the atmospheres will contain what is known as a biosignature, or a trace of life itself. Megan Mansfield, an astronomer at the University of Arizona, predicted that humanity would be able to discover planets that intrigue us and perhaps harbor life. However, we won't always be able to spot life right away. The only planet in the cosmos where life has been discovered so far is Earth. Despite over 60 years of sending probes to Mars, no Martians have been discovered. However, it is conceivable that life could be hiding beneath the surface of the red planet or on a moon of Jupiter or Saturn, waiting to be found. Some scientists have maintained that Venus might harbor Venusians despite its burning environment of sulfur dioxide clouds. Even if Earth ends up being the only planet with life in our solar system, there are many more solar systems in the cosmos that include planets that are classified as exoplanets. Over 5,000 more exoplanets have been discovered in recent years by scientists. Some of them are much more like Earth. They are nearly the same size, composed of rock rather than gas, and they orbit in a region known as the Goldilocks zone around their star, where they are neither too close nor too far to either get roasted or frozen. Unfortunately, these exoplanets have been incredibly challenging to investigate because of their small size. However, this will change with the advent of the James Webb Space Telescope, which will serve as a magnifying glass for astronomers to examine these planets more closely. The telescope left Earth after being launched, traveling 1 million miles before beginning its orbit around the Sun. Its 21-foot mirror is shielded from the Sun's and Earth's heat and light. As a result, the telescope can pick up weak, far-off glimmers of light, including those that can provide new information about distant planets, even in this extreme darkness. As the first significant space observatory to do so, the Space Telescope was built with the study of exoplanet atmospheres in mind. The 7 planets that circle the TRAPPIST-1 star will be studied by a number of astronomy teams. Based on earlier observations, 3 of the planets may be in the habitable zone. The TRAPPIST-1 planets will be observed beginning around July 4th, and Olivia Lim, a PhD student at the University of Montreal, remarked that it is a great area to seek for indications of life outside of the solar system. The habitable zone of TRAPPIST-1 is closer to the star than that of our solar system, since it is a tiny cold star. Because of this, the star's possibly habitable planets orbit close by and complete one full rotation in just a few days. Scientists can answer a simple but important question every time a planet passes in front of TRAPPIST-1. Do any of them have an atmosphere? Nicole Lewis, an astronomer at Cornell University, stated that even if a place is in a habitable zone, it is not habitable if it lacks air. The lack of atmospheres encircling the planets of TRAPPIST-1 would not surprise Dr. Lewis and other scientists. However, even if the planets had atmospheres when they were first formed, ultraviolet and X-ray radiation from the star may have long since destroyed them. According to Dr. Mansfield, a planet's whole atmosphere may be removed before life could even begin to exist there. Whether these planets could have an atmosphere long enough that they'd be able to create life is the first-order question we are attempting to answer. A planet will cast a very little shadow as it passes in front of TRAPPIST-1, but it will be too small to be seen by the Space Telescope. The telescope will instead notice a little dimming of the starlight as it passes. A planet with an atmosphere would affect the star behind it differently than a planet without one. Despite the gas's ability to absorb specific wavelengths of light, some of the star's light will travel clear through the atmosphere. TRAPPIST-1 will become considerably fainter if observers focus entirely on starlight at those wavelengths. These observations of TRAPPIST-1 will be transmitted back to Earth by the telescope. Then you receive an email saying, "Hello, your data is available," according to Dr. Mansfield. However, TRAPPIST-1's light will be so dim that it will take some time to interpret it. According to Dr. Smith, your eye is accustomed to handling millions of photons each second, but these telescopes are only gathering a small number of photons every second. Exoplanets passing in front of TRAPPIST-1 must be distinguished from minute oscillations created by the telescope's equipment before Dr. Mansfield or her other astronomers can investigate them. To see the teeny tiny signals, Dr. Mansfield said, "A lot of work that I actually do is making sure that we're properly correcting for anything unusual that the telescope is doing." Dr. Mansfield and her co-workers might find an atmosphere surrounding a TRAPPIST-1 planet as a result of their research, but that outcome by itself won't show what the mood is like. It might have a high nitrogen and oxygen content similar to Earth, or it might be more like Venus's poisonous stew of carbon dioxide and sulfuric acid, or it might be a combination that researchers haven't seen before. Because each type of molecule absorbs light at a particular spectrum of wavelengths, the James Webb Space Telescope, also known as the JWST, may prove to be powerful enough to identify the precise components of exoplanet atmospheres. The weather of the exoplanets will, however, impact those discoveries. Scientists continue to disagree about what would make a reliable biosignature. Only Earth's atmosphere, which plants and algae primarily produce, has a high quantity of oxygen in our solar system. However, oxygen can also be produced when airborne water molecules are broken apart without the help of living things, similar to how both live bacteria and volcanoes may emit methane. There is likely a specific gas balance that can produce a distinct biosignature that cannot be preserved without the assistance of life. A planet may need to be frequently seen by the Webb telescope when it passes in front of TRAPPIST-1 to achieve such a balance, according to Joshua Christensen Totten, a planetary scientist at the University of California, Santa Cruz. The possibility exists that the James Webb Space Telescope will simply be unable to detect biosignatures. That mission might have to wait until the upcoming Space Telescope generation is still more than 10 years away. Then, instead of monitoring exoplanets as they pass in front of a star, they will study exoplanets in the same manner that people observe Mars or Venus in the night sky, by observing starlight reflecting off them against the dark background of space. Could this lead our search for life on other planets closer? Or are we trying to find things in outer space that has never existed from the start? Share your thoughts in the comment section below.